Alright, this video is going to look at 3 different topics real quick. It's going to have scale factor from a story problem, similar figures from a diagram, and angle relationships where we have a triangle or supplementary or complementary angles so you can find the missing measurement. This first question is the scale factor one. It says the distance between 2 cities on a map is 3.5 centimeters. The map uses a scale in which 1 centimeter represents 20 kilometers. What is the actual distance between the 2 cities in kilometers? I'm going to start out with what's the important information to get going. And it says in the first sentence that the distance on the map is 3.5 centimeters. Then the next sentence says that the scale for this map is supposed to be 1 centimeter represents 20 kilometers. So when you look at a map, it has like a key or a legend and it tells you the distance it's supposed to be in real life. The way I'm going to set this up is I'm going to say what my scale factor is when I start out, just so I can get the relationship between centimeters and kilometers. And that should not say scale factors, just scale factor, sorry. My scale factor is 1 centimeter equals 20 kilometers. Then when you look at the story, it says really on the map that the cities are 3.5 centimeters. So when I get ready to put the next part of my question, this is the number I'm going to use for centimeters and the kilometers are missing. So underneath that, I'm going to line this up. This is how I do it. I put the same unit of measurement on the same side. So 3.5 centimeters equals, I don't know, kilometers. And if you would rather put an X there, you can. When you solve this problem, this one's going to be pretty easy because it says if one thing is supposed to be 20 and now I have 3.5 of them, really all I need to do is multiply these two numbers together. When you multiply these, 3.5 times 20, I like to put my 0 out on the end and then just bring it down. 5 times 2 is 10. And then 2 times 3 plus 1 more is 7. Now this is not a multiple choice answer, it's a griddable, and you need to make sure you get your decimal in the correct place, and then when you come over here to put your answer in the grid, the digits have to be in the correct columns. Right now this says 700. I need to make sure I put the decimal in the right place because this question had 1 digit behind the decimal, the 5. If I move my decimal point back 1 time, now I can see that the answer is supposed to be 70. When you come over and you grid your answer, I'm going to zoom in just on this part a little bit. The number 70 is a whole number, so 70 goes in front of the decimal. You can't put 70 just starting over here with 7 and 0 because this column right here means 7,000. So you have to make sure and put it the first 2 spots in front of the decimal and not behind the decimal because that means 70 cents if you think about it in money, or 7/10. So make sure 70 for your whole number. This question has the diagram, and it says these 2 triangles are similar. The one's just larger than the other, but they're proportional, so there's a relationship between their side lengths. And the question says find the value of x. That's all I need to do. Find the value of x. X is located on this line in the larger triangle. So the segment that matches up in the same position is also this line. When I put these together, kind of like when I just did the scale factor question, I'm going to line these up underneath the shapes. This one is 15 centimeters, and it's in the same position as X centimeters. You have two choices. Since you know both of these line segments, you can pick the one you want. I usually tend to try to work with whole numbers instead of decimals, but it's your choice. You'll still end up with the same answer. I'm going to pick the 18, and then the one that corresponds with that would be 12 in this section. I also like to color code my line segments just so I can see visually which ones go together. That means the 12, which is in the first triangle, is going to go under the 15. And then the 18, which is in the second triangle, is going to match up with X. Now, here's something that I'm going to show you to help with the answer choices, or to help you know if you got the right answer. If you take a look, 15, this is larger than 12. That tells me for sure the relationship on this side, this missing number, has to be larger than 18. So I'm going to draw some arrows down to that. 15 and 12, that top number is bigger. So when I come over to this side, I just got through saying that the missing number had to be bigger than 18. If you go over and look at your answer choices, you can cross out these two because these are not bigger than 18. Not greater than 18. So the rest of the problem, I'm going to have to really work it out. And for me, on my steps, I like to do cross multiply and divide. So when I cross multiply, I'm going to get these two to multiply and then divide by 12. I'm going to put that down as a step for you guys. First step, I made my proportion. Second step, I'm going to cross multiply. And when I cross multiply, the two numbers I'm going to do are 15 times 18. I'm running out of space, so I'm just going to tell you without working that out, that is 270. Then the third step would be divide. And the number I haven't used yet is 12. So 270. Oh gosh, I wrote that backwards. Let me erase that. Okay. 270 is supposed to be divided by 12, not into 12. 12 goes into 270. When you go up here and look at your answer choices, it's either going to start with a 2 or it's going to start with a 3. So that's all I need to do to end up finding the right answer. If you look, 12 times 2 is close to 27. It's 24. Then when I subtract, I have 3 left over. I can bring down this 3. I could keep going, or I want to do as little work as possible. So now I know for sure the answer starts with a 2. And for me, that tells me that the answer is definitely F. This last question, I'm going to look at two diagrams. It also does say find the value of X in each diagram below. This relationship on the left, we have a triangle. And all triangles, the relationship between those is that they have to equal 180. The total is 180. I'm going to list out the angle measurements, the amounts that I know in each corner, 30 plus 85, and then I have 2x minus 5. I'm going to set up an equation underneath this. 30 plus 85 plus 2x minus 5. And all that's supposed to equal 180. And I'm going to shrink that so I have some space to keep going. Before I want to put some of these things together that are the same. So when you look, the 30 is a regular number, 85 is a regular number, 2 has an X, so no, but then subtract 5, that's a regular number. I'm going to circle these, and then I'm going to put them together. 30 plus 85, but then this says take away 5. When I combine them, 30, 85, goodness gracious, 30 plus 85 is 115. And then it says take away 5, not add 5, it says take away 5. When you take away 5, that gets 110. The other thing left in the question is just 2x. So when I set this problem up now, I'm going to make it easier with less numbers. It's going to say 2x plus 110. That gets my whole triangle, which was 180 degrees. Now I can just solve it. Some of you may be able to do this part in your head. However, it's good to show your proof and evidence. Instead of adding 110, I'm going to take away 110 to get rid of all those numbers except for the value of x. 180 minus 110, that's 70. Those things cancel out. And what I have left over is this 2x right here. So I'm just going to bring it down underneath and say 2x equals 70. 2 times something equals 70. If you know that, awesome. If not, set up a dividing problem and see what it equals. 2 divided into 70. Half of 70 is really 35, but I can go ahead and put that on here for you guys. Then you have 10, and 2 goes into 10 5 times. Up here on my question, I'm going to say x equals 35. The missing value was 35. And again, just for us in a second, I'm going to shrink this so I have more room for my next diagram. This one's not a triangle, it's a straight line, or this relationship is supplementary. Supplementary angles or a straight line, those are supposed to equal also 180 degrees. If you had a complementary angle relationship, that would be 90 because it would be a right angle. But this one, straight line equals 180. I'm going to go about solving it in the same way. I'm going to take this first angle, I'm going to put what it is supposed to be. Then I'm going to take this second angle, and I'm going to write down what it says. First angle was 2x plus 3. Then second angle says x. That means 1. 1x. Then minus 6. And again, this relationship also is supposed to total 180 degrees. We're going to combine the things that are alike, just like in the previous one with the triangle. Regular 3, take away 6. I'm going to put those together. Regular 3, take away 6. I'm subtracting a number larger than what I start with, so that's going to be a negative answer, and it's going to be negative 3. Then the next step, I'm going to put the variables together, 2x and 1x. Together, those make 3. Now, in a simpler equation, 3x minus 3 equals 180. To solve it, I'm going to work it out like a regular equation. Instead of taking away 3, I'm going to add 3. Those cancel out. On the right side, it says 180 plus 3. That makes 183. And then again on this side, I have 3x. I'm going to bring it down and put it here. 3x equals 183. If you know it, great. If not, let's set up a division problem. 3 divided into 183. 3 can divide into 18 6 times, and that's a perfect match for 18. And then I drop down this 3 I have left over. 3 goes into 3 one time. Therefore, on this example, the missing value, x equals 61.